Hello, this is Khurram Nasir and you're watching Optometry with Khurram, and today's topic is actually the second part of the RGP lenses, right? And the first question that an optometrist can think, or the optometrist frequently asks, and that is, how can I choose my first RGP lens? The initial RGP lens, and the answer is very simple. Answer is very simple, and that is base curve, right? So the base curve, what is actually the base curve? For example, if this is a contact lens, if this is an RGP lens, right, and this is the lateral view of the RGP lens, right? So base curve is actually the radius of curvature of the central posterior portion of your RGP lens, right? And remember, this is the contact lens, this is anterior portion, front portion, this is posterior portion, and the base curve is actually the radius of curvature of the posterior part and the central part. So this is central part and this is posterior part. So this the radius of curvature of this specific portion is called the base curve, right? So this is called the base curve, and you know the base curve is very important while we are dealing with the RGP contact lens or any type of the contact lenses, right? Particularly and especially in the RGP lenses, right? So the base curve, we can measure the base curve in two different units. One is millimeter and the second one is diopters. So you can have base curve in two different units, millimeters and diopters. And how can I calculate, or how can I find the base curve of the contact lens? Simply with the help of the corneal curvature. And how can I find the corneal curvature? With the help of with the help of the keratometer, right? And what is keratometer? Keratometer can calculate measure the central corneal curvature of the cornea, right? So we can have the central curvature of the cornea with the help of the autoref, which is carrying the keratometry as well, and with the simple separate keratometer, right? So when we will have keratometry of the central cornea, we will get K1 and K2 readings, right? So K1 and K2, these are two different meridians of the cornea, of the central cornea. Number one is the steeper meridian, and second one could be the flatter meridian, right? So for example, if I have 7.84 K1 and 8.00 K2, right? So these are two different, the K1 and K2 readings, or the keratometric readings, right? We also have the keratometric readings in diopters as well. So now we will discuss that how can we convert the keratometric readings or base curve, right, from millimeters to diopters and diopters to millimeters. So we can pick this value 7.84, which is in millimeters, right? And the formula is very simple: 337.6 over diopters, right? So for example, if I have millimeters, right? So millimeters, we have 7.84 in millimeters. So then we will put the value over here, 7.84. The answer will be 43 diopters. So for example, if you have K1 reading in 7.84 millimeters, with the help of this formula, you can convert this millimeter into diopters, right? And assume you have 7.84, you have 43 diopters, you have, base curve, or you have K1 reading into dioptric form, dioptric value. You can simply add the formula and you will put 43 diopters over here, and the answer will be 7.84, the same. So this is how you can convert the millimeters into diopters and diopters into millimeters. And now, how can we find the appropriate base curve for the RGP lenses? There are two different answers, right? There are two different base curves, right? The first is called the initial base curve. So how can I find my initial base curve? Remember, if you are dealing with the RGP lenses, you have to have two different, the base curve. Number one is called the initial base curve, and after that you will find, the final base curve. And how can I rule out the initial base curve with the help of the keratometric readings, right? For example, if I have K1 7.84 and K2 8.00, right? These are my patient's K1 and K2 readings of the cornea, the central cornea, right? So now I want to rule out what is my initial base curve, and that is I will choose the flattest one, So I have two different, keratometric readings, and how can I find that which is the flattest one, this one or this one, 7.84 or 8.00? Remember, if your keratometric readings are in millimeters, then the bigger the value in millimeters, the flatter will be the value, right? So this is bigger, 8.00 is bigger value, 7.84 is lesser value. So in millimeters, the bigger value will be the flattest one. So 8.00 millimeter will be my initial base curve, right? And for example, if I have K1 readings and K2 readings, assume K1 is 43 diopters and K2 is 44 diopters. Now, the smaller the value in diopters, the flatter will be the keratometric reading, right? So we have 43, we have 44, right? So the smaller value is 43, right? So this will be the flatter meridian. And more the value in diopters, steeper will be the value. So this is the more in diopters, the more steeper. The less in diopters, the flatter will be the base curve. The flatter will be the keratometric readings. So now we will discuss that how can we find my final, final base curve. That was the initial base curve, and now we will rule out that how can we find the final base curve. And we can find the final base curve with the help of the fluorescein, right? So for example, we insert the RGP lens on the patient's cornea. We instill, the fluorescent dye, which is in, orange color. And you know very well what is actually the fluorescence phenomena. What is fluorescence phenomena? For example, if I instill fluorescent inside the patient's eye, and I on my slit lamp and I on the blue cobalt filter, and when I strike the blue cobalt filter light on the patient's cornea on the RGP lens, right? And when blue light, which is having the shorter wavelength, if I put that shorter wavelength blue light on the fluorescent, right, the fluorescent will emit the longer wavelength, which is in the green color, right? So I can observe the green color or the green, phenomena in the patient's eye on the RGP lenses, right, on the cornea. So we have to find that we will observe actually three different fitting philosophies in the fluorescent when I will instill the fluorescent. And the number one is called the alignment fit, second one is called the steep fit, and the third one is called the flat fit, right? So what is actually the alignment fit? Alignment fit means that your RGP lens is totally compatible with the cornea, with the shape of the cornea. The RGP lens and the cornea are compatible. There is no any problematic thing in fitting of the RGP lens. This is called the alignment fit, right? And what are the characteristics of the alignment fit? Number one, for example, this is cornea, and this is over the cornea. This is RGP lens, and behind the RGP lens, right, there will be a complete symmetrical distribution of the fluorescent. Complete symmetrical distribution, as you can see over here, right? So this is a symmetrical green portion which is showing the fluorescent in a symmetrical way under the RGP lens, right? And there is small, the least, central touch, right? At the apex, there will be a small least touch of the RGP lens on the central cornea, right? So number one, the number one characteristic is, light central touch. Central touch means this black areas, if you can see, right? It's small, the least one, not the biggest one, not the prominent one, right? So light central touch. Second one is called smooth and symmetrical fluorescent distribution. The whole fluorescent will distribute evenly under the RGP lens, right? And even peripheral edge clearance, right? Edge clearance mean this portion, if I can have the green marker. So this portion, this is called edge of the lens. And edge clearance mean there will be more green area, there will be more green fluorescence at this point. So there are three portions. Number one, even this portion is called even peripheral edge clearance. Edge clearance mean more fluorescent, more green fluorescence, right? And the second one is called smooth symmetrical fluorescent distribution. The whole liquid, the whole fluorescent will evenly distribute over the RGP lens, under the RGP lens. And the third one is called light central touch. The contact lens will least touch at the center. These are the characteristic of the alignment fit. And now we will discuss about the steep fit, right? What is steep fit? Steep fit mean, if I can make you understand in a better way, listen. For example, this is cornea, right? And this is RGP lens, this is cornea. And what is steep fitting? Steep fitting means the edge of the RGP lenses are look like this. They will press the cornea at the center, like at the periphery, like this. And when these edges will press the cornea like this, there will be more space between the lens and the cornea, right? Like this. And if there is more space between the lens and the cornea, the fluorescein will collect over here at the central portion, right? It will get a pull, right? Like this. So at the central point, there will be a pulling, the green pulling of the fluorescence at the center, right? This phenomena is called apical clearance. What is apical? Apex means apex. Apex means center of the cornea. And apical clearance mean more fluorescent at the center, right? So if the apical clearance or the steep fitting is look like this, there will be more space, and if there is more space, there will be more pulling, there will be more fluorescent at the center. And that is called the central pulling. In steep fitting is called apical clearance. Apical means center, and pulling means more fluorescent at the center, because there is more space between the lens and the cornea, right? So this is called steep fitting. This is actually a representation of the steep fitting. And what are the characteristics? Number one, bright green central pull, as you can see over here, right? Mid peripheral bearing. The bearing, what is bearing now? Bearing is actually, for example, if I am having this hand and my other hand is like this, so actually this hand is bearing the weight of this hand, right? For example, if I am having these markers, so what is bearing? Bearing means if I put this marker like this, so the weight of the marker is bearing by my hand. My hand is bearing the weight of this marker. So this is bearing. Mean the both surfaces are touch. Keep in, right? So the mid peripheral bearing, it mean this black area. This black area. So the lens will touch. In steep fitting, lens will touch at the mid periphery. This is center, this is mid periphery, and this is periphery, right? So the lens will touch, the RGP lens will touch the cornea at the mid periphery at this point. So this is, what is the characteristic of the steep fitting now? There will be more pulling in the center, in the apical area, and there will be a blackish area bearing at the mid periphery, right? So this is called the steep fitting. And now finally we have a flat fitting. We observe a phenomena in the flat fitting which is called apical bearing, right? In steep fitting, we observe apical clearance, right? Clearance means more pulling at the center, more fluorescein at the center due to steep fitting, right? And in flat fitting, we observe apical bearing, right? So apical bearing means there is no any gap between the lens and the cornea. They are stick together. This is called bearing, right? And clearance means there is more space between the lens and the cornea, and there is more pull, there is more fluorescence between the lens and the cornea, right? So there is a difference between apical clearance and apical bearing, right? So apical bearing, if you are having apical bearing, it means the fitting is flat, right? And fitting is flat means, for example, flat fitting means this is cornea again, this is lens, and it will look like this. The central area of the cornea will attach the central portion of the lens will attach the central portion of the cornea like this. And there will be gap between the lens and the cornea. There will be more gap between the lens and the cornea. So central area which touch the central area of the cornea, the central area of the lens will touch at the center. And there will be more space between the lens and the cornea at the periphery, right? So because at the center they are touching together, there will be a blackish area at the center, and that is called the apical bearing, right? If the central portion is black, that will represent like this. This is black area, and that is represent the apical bearing. Apical means center, bearing means they are touching together, right? So that's why it will look like a black area at the center, and that is called apical bearing. And apical bearing represents the flat fitting, right? So what are the characteristics of the flat fitting? Dark central area, which is called apical bearing, and mid periphery, bright mid periphery. Now in this case, in flat fitting, the mid periphery will be brighter, the green brighter, like this, because at mid periphery there is a gap between the lens and the cornea, right? So this is actually the flat fitting, right? And if we have steep fitting, there will be less movement of the lens. In steep fitting, the lens will move hardly, right? Barely, right? And there will be poor tear exchange. There will be no tear exchange in the steep fitting, right? And in contrast, if we have flat fitting, we will have excessive movement of the lens. And So that's all. We will see you in the next videos.